Hello, everyone, and welcome to another episode of Learn with Jason. Today on the show, we're bringing back Shaundai. How you doing?
I'm doing great. Glad to be back, Jason. How are you?
I'm doing so good. I'm always any opportunity to spend a little time hanging out with you is a great day. So I'm looking forward to this. It's going to be a whole lot of fun. I wanted to just, I guess, let's start for folks who have not heard of you before, and maybe just give a bit of a background on who you are, what you do, all those good things.
Sure. Yeah. My name is Shaundai Person. Pronounce it like a day of the week, Saturday, Sunday, Shaundai, and you won't forget it. I'm a senior software engineer at Netflix. I work on the front end. So a lot of the stuff that I do, it's in React, TypeScript, also GraphQL, which I didn't know before I started with Netflix, but I've jumped into the deep end, learned a ton. I work on the productivity engineering team, so we make internal tooling for other Netflix engineers.
Ah,
And outside of
yes.
work, I parent. I do conference talks. I love to speak, and I also am working on a course on TypeScript that
Oh, all right.
yeah, hold for a bit, but now we're back in the swing of things after Thanksgiving. But it's called TypeScript for JavaScript developers. So if you're interested in
Great.
updates, ts4js.com is where you can go.
ts4js.com. You're just going to drop one of
Yes.
those right into the chat. Um, Here we go. Is this stream going to upload on YouTube? It certainly is. Yeah, we got Brandon's in here. Couple first-time
There we
chatters.
go.
Hello, everyone. Hello, hello. Okay, you said two things that I think are really interesting. So the first one is you called it internal productivity. Is that what it was? Okay.
Yes.
So
Yeah.
this is a field that I find absolutely fascinating because as far as I can tell, it's sort of new, like not like new, but like last decade or so new, where companies are hiring developers to build their products, but then they're also building teams that work on not external products, but like internal products. So
Mhm.
I think a lot of people are maybe hearing about this for the first time because it is something that the company's got to be a certain size to be able to invest in, like an internal tooling team. So for folks who are at smaller teams, what does that mean? Like, what are you doing on an internal tooling, internal productivity team?
Yeah, so that's a great question. And it could mean a number of things. So at my last company, I did a little bit of that, even though it wasn't a formal productivity engineering team. But the company size was, I think, in total 400, with
Mm-hmm.
a very small subset, maybe like 50 of those being engineers. And so some of that work that we did to serve other engineers was build a component library and make sure
Mm-hmm.
that it was flexible and extensible enough to get plugged into all of the other tools that the team had. We had to be cognizant of making sure that it was the things that we were building is kind of framework agnostic, language agnostic, because
Mm-hmm.
we would acquire companies, adopt their repos, their tech stacks, and have to be able to plug in buttons and headers and things like that into the stuff that they already had that was up and running, had users already. So that was a lot of it. What I do at Netflix, I find really interesting because I'm kind of feeding my own persona.
Mm-hmm.
So one issue, I'll use the word issue. One challenge when I first started at Netflix is, and is still probably something that I struggle with, is just figuring out what tools do what. And at Netflix, we have different teams that will either build a brand new system that we need, like let's say monitors the health of a repo and
Mm-hmm.
or like alerts you on security updates, different vulnerabilities, kind of like GitHub Dependabot does, right? So we have all these disparate systems with all of these very cool and clever names like Vulkan and Spinnaker, but it doesn't tell you exactly what that tool does. It's like, as a newbie, you're just supposed to figure it out. So one thing is just like discoverability. How are engineers, new and senior,
Mm-hmm.
how are they discovering what tools are? that they need for their daily work, and how do those tools interact with each other, and then how can we build an experience so that developers and with your work at Netlify, you're probably very in tune with this, but like as a developer, what is your experience like
Hmm.
how easy is it for you to stand up a local environment? How easy is it for you to troubleshoot a weird bug? How often are you notified about different security vulnerabilities?
Got
So we
it.
have to be in tune with our customers all the time. And then we're finding the problems and then solving those problems. So it's a lot of, I think the fun part is that a lot of it is stuff that isn't done already. We're like building it new or deciding whether there's another company that does it better that we should just buy it or
Right,
not.
right.
So yeah, there's no precedent for a lot of it,
Yeah.
which is fun.
So this is what I find really fascinating about it is that, each company, like there's a reason that people are spinning these teams up. And it seems to me that what we're finding is there's the value in something off the shelf, because a lot of times you can just reach for, like GraphQL you mentioned is a good tool for bringing together a lot of disparate systems and giving your team a normalized interface. But before GraphQL, what were teams doing? Before, like, what happens when you have a bespoke internal design system and a bespoke internal reporting system and a bespoke internal thing? You can't use off the shelf tooling anymore because it doesn't interface with any of this stuff, right? And so you find yourself with these very unique needs, and it costs real money to have a developer who takes a month to spin up because it takes forever to figure out what are the tools, where are the environment variables, how does this thing work, how does that thing work. So I found, like, I've never worked officially in internal tooling, but I sort of accidentally started it at IBM. Because when I was there, we were the front end team, but like the starting process for a day one front end developer was install Nginx, install. You need to put these firewall rules in place. Here's how you get the reverse proxy running. Here's the Docker image that you need. And I was like, okay, I've been doing this for a long time and I've never done a lot of the things you're asking people to do. And y'all are running a front end boot camp where people are coming
Yeah.
out after 9 months and this is their day one. Like, there's no way
Oh my
this is possible. There's no way this is productive. And so,
God.
I ended up just kind of trying to, like, what if we rebuilt this a little bit? And I built a little like template that you could npm install, like IBM boilerplate from our private npm instance. And it auto configured all that stuff for you in a way that like a developer could just install a new thing and it was running. And
Oh,
it
that's great.
had we could do centralized security updates because we had a literal team whose job was doing a round robin of the 30 plus different teams in IBM Cloud and helping them do security migrations for the year. So they just had to, like,
Yeah.
go to the team, fix their stuff, go to the next team, fix their stuff. Meanwhile, all the other teams are drifting further and further out of compliance. So it was like this game of whack-a-mole that they could never win.
Oh my God.
And
Like this is my exact life right now. But
yeah, right. So this is the importance of internal tooling, because some things you can't fix. Like internal training, you just need to keep doing it. You will always need somebody who goes around and teaches the team's best practices and so on and so forth. But a lot of this stuff, like whether or not the software is properly interfaced with like the right security rules or the right internal checks or whatever the things are, you can build that in one place and then deliver that to teams as a tool, as opposed to, hey, copy paste from this repo that did it right, and then everybody has to copy paste every time it changes, right? There are these little things that you can do if somebody has time to do it, and that's internal tooling.
Exactly, exactly, right, and it just enhances from day one, because think of yourself as that brand new developer who comes in and is like, "Oh my god, I just started this new job," whether it's at Netflix, whether it's at a smaller company, you're feeling a little bit of imposter syndrome, or you're feeling kinda
Mm-hmm.
overwhelmed with all the stuff that there is to know, but just imagine, that developer comes in on day one and is able to, like, push up a PR or, write some code that goes into production eventually. Maybe not on day one, but it just does so much to enhance that person's experience at the company from day one, and then things go on from there. I think it just makes your company more of your engineering team more of a well-oiled machine overall. So
Absolutely.
it's important.
Yeah. Yeah. I think it's okay. So, anyways, that's not what we're talking about. Well, we're kind of talking about that today.
Yeah.
So one of the things when we talked last time, one of the things that I enjoyed the most is how good you are at analogies, because I remember we were talking about like React and React children and all these things. And so that's part of what I'm really excited about today, because we're going to get into something that is very heady, which is React performance, right? And I think we're gonna need you today, because this is stuff that is confusing no matter how long you've been in the game. So let's talk a little bit about this. Why? Where do we even start? Where's the right place to start with React performance?
Yeah. So the first thing that I want to say is that the things that I talk about, like a lot of people will ask, like, well, then how do I optimize a React app? And obviously, maybe not obviously, but it depends. Like
Obviously.
it depends. Yeah, it depends because there are a lot of ways that you can optimize things, but there's an art to it. You want to
Hmm.
be very strategic in the way that you do it. You don't just throw the whole kitchen sink of, oh, I could do this, I could do that, and I will do this every single time. It really depends on your users, what your tech stack is, the way that you have your React application set up. But there are different tricks that you can keep in your back pocket that will help you, and then over time you can make the decision for yourself, like, is this something that I want to use? There's not any one technique or pattern that is the best. Like with every technique, pattern, language, there's always trade-offs. There's the great things about it, and there are the trade-offs that happen with that. So anything that we talk about today, just going with that lens that it's not the perfect solution for every single case. Um, yeah. So I did a talk in September here in Atlanta for a conference called Refactor Tech.
Hmm.
And this talk was about performance. And it was called ELI 5 Technical Terms Decoded, I think. But basically what it was just like me just spitting out analogies for different tech terms. And explaining it like I was talking to a 5-year-old, which, as you know, Jason, is like, that's my jam. I love to, I love to do that. Um, so I tweeted probably last year, asking people, like, if you could have an ELI 5, which stands for explain to me like I'm 5, the explanation for any technical terms, what terms would you like me to explain? And I noticed that a lot of the terms that I was getting had to do with the realm of like optimization, performance, interactivity. And so I just kind of bucketed them together and put it into this talk where I talked about performance. And so to get to your question, where do you start? The
Hmm.
first thing that I start with a React application is just talking about the different steps of rendering, which is the overall process of when a user makes a request in the browser. What happens from the moment that they make that request to the time that the request is completely fulfilled, meaning that the user can interact. And at any stage is where you can find ways to optimize the performance. So those 4 stages are, and this is typically in a server rendered application, but also in a client rendered app, is first you will fetch the data for the app. The next step is that you will render the application as HTML in the browser. The next step is that you will load the JavaScript for the app. If you're doing server rendering, you're going to do this part on the client, where the other parts
Hmm.
will happen on the server. And then the last step is where we hydrate. So at any of these stages, there are different tricks that you can put in your back pocket for optimization. And you'll hear about different ones like suspense, memoization. The one that I wanted to talk about today is called virtualization. But there are different ways to optimize the performance of your app from each
Yeah,
of those
and
stages.
and this is one of those things that, as you said, it's so context dependent, right? Because I think one of the biggest pitfalls that almost every engineer falls into when they first start doing things with performance is they start to think about performance at the expense of everything else. And you'll see people write really convoluted code or walk away from a known solution or whatever it is because they'll say, well, I heard that that's not performant. And it's like, my dude, you're putting 5 components on a page. You're not at a stage where you got to worry about micro optimizations. Like, you know, you can worry about these things when you get to the point that performance is a bottleneck. But like, in the meantime, just, you know, make the thing. Like, it's okay. You can you can just build it and not worry about whether or not it's performance tuned.
Right. Exactly. Yes. And like you said, like your overall goal, in my opinion, and I feel like I always have to caveat because there's always somebody that's like, well, no, in my case, it's different. But in general, to me, the most important person or the most important persona that you should be thinking about in your code is your user. Strong second is the developer, especially if you're working on a team, you want to enhance that developer experience. But think about what your user is going to need, what features your app is going to need to serve your user in the best way, and then work backwards from there and say, okay, well, if I'm going to be fetching huge amounts of data, or if I need to display huge lists of information, think about your users who have slow internet connections, or take into consideration the fact that when you're server rendering, you have all this data all the way on the server and it's going to have to travel over the network and all the way to the client. How can I minimize this as much as possible? Like, how can I minimize the load in case my user has, like, you know, slow internet, or working from a phone with a really bad connection or something like that. So,
well, and yes. You mentioned like the different phases too, because there's the initial load of the HTML. And when you do hydration, if you've got a big list, you're not only putting that list into the HTML, you're also putting all of the data for that list into a big JSON block at the bottom of the page that then has to be read into memory and parsed and all those things. So like when you get into huge lists, you're shipping it twice and you're processing it at least twice. And that's when you have to start worrying, is when you've got, you know, thousands or tens of thousands of items. You probably don't want to like server render that whole thing, right? That's going to take forever to load. It's going to be laggy as hell. And if anybody has ever tried to render, you know, 10,000 items into a list, you probably saw React not do well with that.
Yeah. And it's funny you mentioned that, because like, as I was preparing for this, I tweeted at you yesterday about how I crashed my browser 2 times. So I was playing with a little demo that I was working on. And I was like, oh, this is simple, because it was just like a list of things. Literally, it was like a div and a word, 2 words. So one word was movie. The other word was like the index. So, you know,
Right.
1, 2, 3, 4, 5. And so I was like, okay, you know, if I render a list of 1,000, cool, that works well. What if I did 1,000,000? And so,
Oh my
like,
God.
instantly just it didn't work. So I was like, okay, I'm not gonna do that again. But I know my limitations. But that's only like mapping over information. I'm not fetching data. I'm not rendering images. I'm not showing any videos and streaming. And so at a company like Netflix, for example, Facebook or Google, where you have huge amounts of information coming in, or let's just stick with Netflix, right? Where if you're scrolling on the Netflix app on your phone, there's like a little preview of a movie. So you have like all of this data from the movie that's streaming, the couple seconds of video, the images, and then all of the metadata that goes along with it. Like, how is this relevant to the user? What's all the, you know, who's the producer? What's that? What's it called? Oh, director of the movie. Like, who's the director, who are the actors, and things like that. So all that information needs to go in. And so that's very like computationally extensive for your browser, your whatever device that you're using.
Well, and especially with something like Netflix, it's not like we can just hit an API and load all movies and then just have it ready when you need it, right? Because it's thousands and thousands of movies and so many data points for each movie, and, you know, chapter markers and all of the metadata and like all that stuff, and a bunch of personalization too, because it's got whether or not it's recommended for you, it's got ratings, it's got similarity to the things you've already watched. Like, so much information is being sent in a Netflix UI. You can't just like download it. So you got to be smart about when that data comes in. Otherwise, you're wasting people's data. You're gonna slow down their computer. Like it's no joke.
Exactly. Yeah. And we pride ourselves, even before I came here, I was like, Netflix is just so easy to use. But we really take pride in the user's experience. More than more than anything, I would say is just like how seamless is it for a user to get
Right.
onboarded, and how often are we having downtime, which, hopefully is never. But it's not a perfect world. But yeah,
Yeah.
we put a lot of effort into performance, and so that's a big concern if
Absolutely.
anybody's
Yeah.
looking to.
Okay, so let's talk a little bit about what you said. Virtualization is what we want to focus on today. So let's talk a little bit about what that means. So this is a concept that I hear people say, but I don't know if I've ever actually heard it explained in a way that has really made it make sense. So what I think in my head is I have 10,000 items that I need to put into a table. I query the database. I got to put those things in a table. That makes the page slow. And then somebody says, virtualization will solve that. And I go, that sounds like magic. And then I stop, like my brain stops accepting information.
That's pretty good. Like, I mean, you're like most of the way there. At least as long as you're on board, like, what more could I ask for real? So, yeah, virtualization is that was actually a really good segue because because of all the stuff that we were talking about. So think about, like, let's use movies as an example. If you are trying to render a list of movies for in an app, let's call it Betflix, right? We that was so creative. So,
Totally made up app. It's not similar to anything else out there.
it might be a little abstract, hard to picture. So you get a list of movies with all the metadata we talked about, the director, when the movie was open, images, all the different artwork, the little previews and things. And you'll probably get that as like JSON, right?
Mm-hmm.
And so as a developer, what you'll do to render that is we'll just map over that information. If we're using like JavaScript or React, we'll map over that information. And then for all of that info, we will like create, a little box, which could be a div or something, and have everything placed nicely in order. And so
Mm-hmm.
essentially what we're doing as we're mapping over it is we are creating a stacked list of divs and then just letting the layout figure out where all of that stuff will go, which is like inside of 2 UL tags, for example.
Mm-hmm.
That's great for the user because they don't have to look at this ugly JSON that makes no sense. But performance wise, it impacts, because think if you have a list of thousands and thousands of movies, and for each of those movies, you have all of this styling, all of these images, these videos, titles, and all of this extensive information. And so for every one of those items that we're painting to the DOM, we're adding that much HTML, that much CSS, that much JavaScript, all the stuff that your data has to, all of the stuff that your browser has to parse. We haven't even actually like fetched data in this example, but imagine
Mm-hmm.
if for each of those, you would need to go and make another request back to your API and say, give me additional information about this movie, or respond to mutations. Like if somebody likes the movie or something, how do
Yeah.
we add that into our algorithm? So for every single one of those movies, you are going to be adding all of this information to the DOM, which is what ends up, crashing your browser like I
Right.
did yesterday. So what virtualization is a technique where we say, okay, yes, we have this list of 1,000 movies, but we don't necessarily need all that because the user isn't actually seeing that. We only want to paint to the DOM the stuff that's in the user's viewable window. So if you think
Right.
of like just your phone as I'm using my face, but like imagine my face as a phone.
We're voguing.
Yeah, there's, just imagine that as the data, and you can think about this if you think about Netflix, Facebook, Pinterest, as you scroll and things are new to the DOM, those items below are going to get painted to the DOM. And then
Right.
as the items get out of your viewable window, we're removing them from the DOM. So the browser doesn't have to keep all of that stuff in memory, and we don't have to load all of that information. So it's called virtualization or windowing.
And
There
so
are libraries. Oh, go ahead.
like thinking about this from the standpoint of, okay, we've got our window here, right? Then if I'm looking at this box here, and we've got lists that are coming in, if I can fit 10 things on my screen, then I'm probably only ever rendering, say, like 12 to 14 of these items, because as they come out of view, they're going to get removed, and then like a new one gets dropped to the bottom so that we can scroll up and down, and it looks like the whole list is there. But as far as the computer is concerned, it's only ever handling like a dozen or so of these components, which computers in the dozens, they got it. It's under control. Right. And so, so the idea then is you are using the magic of the viewport as a kind of an illusion. So you switch from being somebody who is strictly building a full list, where it's kind of that joke about, like, you see somebody in an old timey movie and they've got their list of demands and it's a scroll, and they kind of like unfurl it and it rolls down the stairs and out the door and all that, right? Like, that's the original way. And this is moving more toward, like, a flipboard. You're only showing what needs to be shown, and then you get rid of it and you look at the next one. I don't know where that came from, but I'm actually, you know what? You're a good influence.
Yay! That was great. That was really good. I'm going to use that. That's awesome. But yes, exactly like that. It's just like using a flipboard. And then so React is just like, oh, like they, just short-term memory, forget it, after it scrolls out of the viewable window. So it helps to save your browser from having to make and like hold on to all of these calculations to keep stuff that's rendered that's nobody's even looking at right now.
Okay. All right. So at that, we're about 30 minutes in now. So I really want to start putting some code together here and actually show how this works. So I'm going to take this opportunity to flip us over into the pair programming mode once I get this window out of the way. And now here we go. Camera 2. Oh no, what happened to where am I? Okay, everybody hold up. I'm gonna fix my goofy screen here that I just broke. Why did you? What? It's okay. Hold on. It like says that I'm here, but I'm clearly not here. So we're going to do one of these, and then we're gonna do one of. What's happening? Why are you like this? Maybe one of these. Nope, not like that. We're gonna do. Oh, okay. All right, here we go. We're almost in business. What are you doing? Why?
I'm imagining you're like you're opening a curtain or something.
I don't know. I'm just gonna reset this transform entirely. Okay, now I'm way too big, but that's okay because we know how to handle that problem. And we're gonna go move over here. And that's about the right size, and we're gonna call that close enough. Okay. I don't know what that was. Okay, so with that, let's get down to business here, everybody. It's no fun allowed on Learn with Jason. We are going to talk about we have Shaundai on the show, and with Shaundai, we also have live captioning, which is being provided by White Coat Captioning. And today on the show, we have why can't I get this tab? Just I'm getting everything's making me nervous right now. So we have Rachel with us today from White Coat Captioning, taking down all these words. Thank you very much, Rachel, for being here. And that is made possible through the support of our sponsors, Netlify, NX, and New Relic, whose SVG I've broken, and I think it has something to do with the browser blocker tool that I can't debug because I keep forgetting to do it. So New Relic's in there. It'll probably show up on your browser. I'm in Arc, and it's helping. All right, we are talking to Shaundai today, who you can find. Is Twitter still the right place to send people? I'm not sure, but I'm gonna do it for now. So we're gonna drop your link, You hanging out on Twitter
Cool.
these days, or you on Mastodon now?
I am on both actually, but I'm actively using Twitter. I'm not really sure what the etiquette is. Like, do I
I
post
don't
to
know.
Twitter and then also post the same thing to Mastodon,
I don't
which is what
know.
I was doing. But then I felt like I was copyright stealing from myself.
I feel
I don't
weird
know.
about the whole thing. I don't know. I like Mastodon. It's also very hard to use. I'm confused by the whole thing. Um and
Same.
here we are. I really maybe we get Twitter back. Like that's just give it back. Stop, give it
I
back. I
know.
want it. I want it back.
Yeah, I'm thinking about starting a GoFundMe so that we can all like buy it back.
With a goal of $44 billion.
Yeah. We get like $36 billion.
If everybody in the world just kicks in, what would that be? $8, $9, something, no, $7, we can do it. We could do it.
Honestly, yeah, the babies too. Like,
That's right. That's right. Parents chip in for your kids. Uh, yeah. All right. Should we talk about
I know.
code?
Let's do it. Let's do it. I could talk to you all day about other stuff.
Okay.
Yes, let's talk
All
about
right. What should I do first if we're
okay.
gonna if we're gonna do some React?
let's let's do you use VS Code? I
I
think
do.
you do, right? Okay. So let's just do a new create React app. We can do this
Okay.
one from scratch.
And so if what is it, like npm
Oh yeah,
create?
what is it? I think it's create dash React dash app.
Oh, we're doing like legit create React app. Yeah,
Yeah,
let's
just
do
a
it.
brand new React app.
Let's do
That's
it.
how I always start it. That's one of those things that,
What?
I just do it because
Oh, you
the
have
way
to
I've
give it a
always done
name.
it.
So we're going to create React app and we will call this React Perf Optimization. Or what did I call the episode? Optimize React app performance. That way I can find things later. And we're installing the things that we need so that we can get this thing up and running.
Okay, cool.
I
So,
I've like given in to the Vite hype. I'm always using Vite instead of Create React app these days.
I've never used Vite, so I'm guessing you like it.
It's great. It has all the things that I like about Create React app, and it's also using a faster tool chain. So it's like no more Babel Webpack. So it's like real fast and snappy. And for my apps at least, it's been exactly what I need. Okay, so we're looking at a basic site. So I'm going to pop this open in code and make it a little bit shorter so that we can actually see everything. All right. Wait, I did the I gotta get initialize this or else it's gonna be all dim. So let's get init, and then we'll open it up again. And now we can see the code. All right.
Perfect. Okay, so we're going to, I think in the last one I went through like create React app and the parts of it. I think we could skip over that for this time. But for those who, if anybody isn't familiar with create React app, it is a scaffolding tool that helps you to create a React app. And couldn't guess that. The biggest,
It's good naming.
It's very clever. The uppermost parent is called index.js. So that's where our app is being like exported from. And then app.js is typically the oldest child, the first child underneath it. So we'll work with that. What we'll do is we'll start out with an app that's not virtualized, which would just be like a quick list of movies.
Mm-hmm.
And then we will add some virtualization. So there are tools that you can use to help with virtualization, like React Virtualize. I think somebody mentioned in the comments. That's one of the more popular ones, and that was created by the amazing Brian Vaughn. You can use that. I'm not saying not to use it. This is just kind of giving you a peek under the hood so that you can see how virtualization works.
Got it.
So Yeah. So Jason, why don't we start with, let me make your screen bigger so I can see. Why don't we just get rid of pretty much everything that's being returned in this app? Yeah. And then we don't even need that class name either. Or we can keep it. Yeah, perfect. A to-do. Yeah, let's make a to-do list. And then so the first thing that we want to do is make an array of things that we're going to work with. So an easy way to do that is to use, I like to use array.from.
Okay.
And so we can create a new variable. Yeah, items, and then inside that, so array.from is going to take, in this case, two params. The first param is just like, let's call it an object length is the key. So just put an object inside of that, like the curly brackets
Okay.
inside of the, yeah, and length.
Length, like how many items?
Oh, just the word length. We're going to
Like,
make it, it's going to make it,
like
oh, just write
this?
the word length. Yeah. And then colon, yeah, colon, and then count, because this is going to be a piece of state that we're going to set. And
Oh, I need to put
then,
this inside of my my component then, huh?
yeah.
Okay.
Oh, yeah. And we should import state too, but we can get to that in a sec.
So we're gonna do like a use state.
Yeah, for count and set count. Perfect. And let's start with 1,000. A million is going to break it.
Oh, you want to see a trick that I learned that makes me really happy? You can put an underscore
Yeah.
in numbers to separate them so that you can like see, and it doesn't break the number. This changed my life.
Wow. I'm glad I can see. I'm learning. That's amazing. I'll use that. I love it. Okay, perfect. So we have our count. And so what this items array is going to do, it's going to spit out a length, oh, sorry, it's going to spit out an array of objects. Let me explain this better. So what we will do is, actually, let's add this function first. So the
Okay.
next parameter is going to be a function. And then what it will return is an object with index. Yeah, index is one, and then make that I plus one. And sorry, one of the params should be, there's going to be two params inside of this. So the first one is going to be an underscore.
Not using it. And then the
And
next one is
yeah,
index.
yeah. So this is one trick that I recently learned is, you know how like parameters, you have to make sure that they're in the right spot for React to
Mm-hmm.
recognize it in like the return or whatever. If you have a param that you're not actually going to be using, but you need like the second param, like we need the I in this case, you can just use that underscore and it's just going to ignore
It's
the that.
That's really nice. So like this one up here, see, it's yelling at me because I'm not using it. But we can do one of those, and
Oh,
then
right.
it'll leave us. Oh, how dare you? Well, it usually
Hey.
works. But like here, if we were to do
Okay.
like value, right? Then it's gonna yell because it's
Mhm.
not used. But then you just underscore that shit. Okay.
Exactly. Nobody uses it. I love it. Okay, and so we'll return the index plus one. And the reason we're doing plus one is because, you know, the index, we start at 0. And this is just going to be what the movie name is. And then the next one will be name is the next key.
Okay.
And then let's just call it movie, whatever the index. So let's just call it movie and then I plus one.
Okay.
Yeah, perfect. Okay, cool. So we've got our list of items. Okay, so sorry, to explain array.from, what we're doing is we have a list, and this is going to create a list based on the count that we've set, which is 1,000. It's going to create a list of 1,000 things, 1,000 objects that are that have the index and the name, and it's going to increment them by one at each step. So the next thing that we'll have to do is we will have to map over it. So maybe let's create a function called display movie items or something. So do that above or under items.
Okay.
Yep. And then, so we're going to map over this list of items. And
Should I pass it in
so
as like we want to send the items in?
we don't have to because
I
we
guess it's
declared
all in
items
the,
at the,
yeah, it's
oh,
all in the same
yeah, because
scope.
we have items at the top. Yeah, so the way that I would do it is I'd create a new variable inside of that function. This is all a matter of personal preference, but
Okay.
you could do it exactly that way, Jason, too. Let's just say like movie list, or yeah, movie list.
And then make that
And then,
the map.
yeah, and then we'll map over that.
Okay.
And then we'll display for each of those. Let's put a div, because divs are fun.
And then we need like a key on these, right? So it won't yell at us. So we can do like an item.index. And then,
Yeah. And then inside of that div, just put curly brackets with the name, the i.name, item.name. Cool.
okay.
We're going to add some
then,
styling to this too, but just like pretty basic styling. So we can do that in a sec.
okay. And so then down here, I just want to call this display movie items.
Exactly. Yep.
Okay. So saving this, we get our movies. Here's the giant list of movies. And every single one of these is in the DOM.
Exactly. So what I want you to do, Jason, if you can you open the console to see like how all of the divs are showing up in the DOM? So yeah, we gotta go in.
There we go. So many.
All of those. And you see, and now imagine if each one of those had its own like data requests or images or videos, how extensive that would be. Like I said, I crashed my computer twice because I made this list 1,000,000 instead of 1,000.
Right.
Being silly. And all it is just words. So that's why we want to virtualize it. So if we're looking at Jason's screen right now, we can only see like 40 of these things. So we only want to, the technique of virtualization is going to make it so that only the items inside of the user's viewable window are going to be painted to the DOM. And then as we scroll up, those items will get removed. And so the trick when it comes to virtualization is we're going to have two boxes. One outer box is going to be responsible just for the scroll. And then the inner box is going to be responsible for placing the, it's going to be responsible for kind of containing the window. And how we have done things with our non-virtualized lists is we just like stack things up as we're mapping over them and they just fall where they fall. The trick is that for this inner window, we're going to have this as position relative. And then all of the child elements are going to be absolute. And we're only focused on what the top is for this window and the bottom is for this window. And anything, as soon as it falls outside of that, it's just going to like not be regarded by the DOM right now. So,
I gotcha. Okay.
So yeah, I see you put the inner box and the outer box. Perfect. And you gave them class names so we can give them some stylings too. So that's perfect. Okay, cool. So now that we virtualize this is actually a trick that I found from Stack Overflow, which has been very helpful for me. We'll talk about how to use this tool or this prop called scroll top. So create a new piece of state underneath our count called scroll top and set scroll top. So we'll have this as a piece of state called scroll top, but there's actually an attribute on current target when we have an event. So we're going to have like, based on the scroll event, we're going to calculate what the scroll top, the index of the top element is, and the index of the bottom element is. And we'll use that to be able to determine whether or not movies are within our viewable window. So this one is a piece of state. So let's set an item. Let's set a height for each of these items first. So let's do set a new variable, create a new variable right underneath where you put the state, and then just call it item height. And let's just say 30.
Okay.
Yeah.
And then we just want to like style it here.
Yeah.
Does that work with just a plain value or do I need to? Oh yeah, there we go. Okay, great.
that should work. Yeah, that'll work. And then we want to do a window height so that we'll use it to calculate it. So declare another variable called window height. And we'll just do like 500.
Okay.
That's good.
And then that's
Okay.
going to be in our outer or inner?
That is in our inner. Our outer one, we're going to have to add a style. I don't know if you already did this, but we have to add in the overflow Y will be scroll.
Okay, I'm just doing the overflow Y scroll. Okay.
Mm-hmm.
And now we can see that it's doing the thing.
Yeah.
So now it's scrolling this box, and we can prove this too. So let's go with a border 1 pick solid red so that we can just see what's going on here. So now we can see here's our actual box.
Yes. Perfect. Okay, awesome. So, and did we added a scroll to it. Mm-hmm. We have a height. Do we have a height for the outer? No, we don't need a height for the outer box. Okay, cool. So we're good. And then the height for this one should be, it looks good. Oh, so one important thing is that we need to add position relative to inner box. So
position relative to inner box.
Correct. Yep.
Okay.
And then I think we should be good. All right, so let's add a scroll event to, so let's go up. We can create a new function called on scroll. And so this function is where we're going to set the scroll position. Or sorry, we're going to set what the scroll top is.
Gotcha.
So this function is going to take one parameter, which is E, like event. You can call it event. And then
I am going to call it event because I always forget.
You do? Okay. Okay, let's do that. And then the only thing that's going to do is set the scroll top. So the function that we declared above, set scroll top, to event.currentTarget scroll top.
Okay. So this, whenever this gets called, is going to update. Ideally, we're scrolling here, right? So we're just going to change the value of the scroll top, and we don't need to worry about see, this is where somebody would start panicking about performance because it just happened in my brain. I was like, oh, but every time you scroll, isn't that going to be setting a lot? Yes, it doesn't matter. Computers are fast.
Right. And it's, again, there's trade-offs. So like, yes, that is a trade-off, but like what you're trading off is not rendering thousands of movie titles and all of the data for all of those titles. So, yeah, in our case, it's going to be beneficial.
Okay.
So let's add on scroll to our, the outer div.
Okay.
Because that one's the one that's responsible for the scroll.
There, so on scroll. Okay.
You got it.
Perfect. And then, so nothing's happening. We won't see anything change right now. I guess I could like console log it and we could see the same value here. Let's just grab that.
Yeah, you can do that.
We'll throw one of these, do a little save. Boom. There we go. All right, and then I'm going to turn that off because the console logs get a little messy.
It's looking good.
All right. Okay, awesome. So we're setting the scroll top now.
Okay, perfect. So then the next thing that we have to do, or the next piece of the virtualization, is that each one of the items that we have needs to have its own height, width, and needs to be positioned as absolute. So we're going to need to add some styling to each of these items. So in our div, let's just add some inline styles.
Okay.
Make sure that they're position absolute with, say, 100%. I don't know if we set a width to the inner or outer divs, but
we didn't
if not,
yet.
then Okay, we'll go back and do that. We also have to set a top position. So what this is going to be doing, let's take a step back, is now we know what the top of our viewable window will be. We know what the bottom of our viewable window will be.
Hmm.
And so rather than just like stacking divs up where they go, like you would do as a return from a map function, what it's doing is saying, okay, this is where the top of this div is right now. So absolutely position. This is where we're gonna, or this is where it should be right now. So we're like individually kind of placing each item where it needs to go based on this top prop that we're gonna add in right
Oh, I
now.
gotcha. Okay. Okay.
Yeah. So we have it positioned absolute. So what the top is going to be a template literal, and then inside of that we're going to do the items index. So item.index, and do that multiplied by item height. And then pixels will go outside of those curly brackets.
Okay. And so that
Yep.
starts us. We're all where it should be.
Yep. And okay, perfect. And then another thing that we'll have to do is set a start index and an end index. So I hope I'm not getting too confusing, but what this is going to be is based on what we know about the top position and the bottom position,
Hmm.
we're going to calculate what the index of the item that's at the top is and what the index of the one that's at the bottom one is.
Okay.
And then that's how we know like what's in our viewable window. So up at the top, we could do this probably underneath window height. We'll declare two variables. So the first one will be the start index. And this one, the math works. Just like, don't ask me how it works. So we're going to do math.floor. And then we'll put in scroll top. And that's going to be divided by the item height.
Okay.
Yep. And that's perfect. And then let's do another one called end index, another variable called end index. And that's going to be the same thing, except that instead of scroll top, it's going to be scroll top plus the window height. Okay, so that's telling us the index of the lower. So we could leave it like this, but we also don't want to go past the last item in the list. So we're going to wrap this entire math floor into a math min.
Mm-hmm.
And then what math min will do is it takes parameters and it will give you the minimum of whatever is in there. So we'll do count as one param for this. So math min, yeah, and then that's it. So now we won't go past the last item in the list.
Got it. Okay, so what we have done here to break this down is we're taking the scroll top, which is where we are in the window. So right now it's 0, and then we're dividing it by the item height of 30. So 0 divided by 30 is 0. So we keep it all the way up. We'll get the first index of 0. If we have a scroll top of 300, then 300 divided by 30 is 10. So we would have a starting index of movie 10, right? And then here we're just adding the window height of 500. So that's giving us like our how many items would fit. So when we were talking earlier about on an average screen, right now we can fit 15. With 500 pixels, we'll probably get, let's see, 500 divided by 3. We're going to get like, I can't do math. 18.
Calculator.
That's not right. My math is terrible right now.
500 divided by 3. 166. 16. So you were close.
Yeah. Okay. All right.
You said 500 divided by 3 or 30?
By 30.
Oh, 30. Oh, 16. Yeah, 16. You were close.
Okay. All right. So yeah, we should get 16. I'm zoomed in. That's why that seems so incredibly high. let me zoom out. Okay, this makes more sense.
Oh, perfect. Okay, yeah.
I was like, why is that so tough? There's no way. Okay. So, all right. So I am going to zoom back in a little bit. Okay.
I'm glad we got to see that because you got to do the math first. And then yes. So that's the index for the item that would fit at the top and the item that will fit at the bottom. And so React is like, okay, those are the only, like between those are the only ones that I'm gonna paint. And so now instead of using our just our array that we created with the full blown 100 list of 100 items, what we can do inside of our display items function is we can slice and say, out of this array, I only want to take items between this number and this number, map over those, and those are the ones that I'm going to be showing. So, boom, you got it. You got
Okay.
it.
And so slice is dope because it just says, give me the items from this one to this one. And then we will map over this instead. And I broke it.
You know what? I remember we forgot to add height to the outer div. And let's make sure that it's right. So it's the funny thing about CSS is that it doesn't always, it's not always intuitive. So you do have to set a height width for the outer one. And then we could do, yeah, let's do height is, what did we say? Yeah, for the window height, that was 500. Let's do width is like 300. Yeah, that's perfect.
That's too many. Okay.
Too many?
And then we can do one of these margin, like 0 auto so that it's centered. Ta-da! Okay.
Beautiful.
But I've broken something else.
Let's see. Position
Does the
relative.
inner box need a width?
It shouldn't, but change that window height. Do we have an inner height item?
Inner
I think that's
height.
why.
Sorry,
we should have. Oh, sorry. We should have a variable called inner height, but I don't think we did that yet, did we?
We did not.
So, okay. So, yes. All right. So the outer box is just responsible for the scroll, and let's make that. Count. That should be count times the item height.
Okay, and then
so yes, this
window height.
Yeah, and
inner height. Okay, I'm breaking something else. I have clearly typoed something. So let's poke around in here and see what we're seeing. It's not rendering any items, which means that something I'm doing is not working, which means we are going to play the console logging game.
I love this game.
So we'll do displayed items, start index, and end index just to see what the heck is going on in our code. And we get displayed items is 0. We are, not a number, not a number. We made a mistake. What mistake did we make? Scroll top.
Like, I really do.
Oh, scroll top is got to be initialized at 0 is why.
Oh.
I was leaving it undefined, and when you divide undefined by anything, it's not a number, which is, that makes sense. That's how math works. And so look what's happening. Look, see it popping out? Bop, 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 bop.
Boom, bam. Oh, look at that. Now console log that. And I'm going to show you, because remember how we had 1,000 movies on the console? In the Elements tab. Now let's look at it as you scroll.
As I open up all my divs, here we go.
Yeah.
So 1, 2, 3, 4, 5. There's 17.
17. Now, if you scroll, look at that, and then you go up, and you see it's
dropping off.
Number 1 is gone. Number 2 is gone.
See,
that's how we get them out of here.
And this is something that's like where this is going to matter is not in this list. I mean, it kind of matters. Like 1,000 is not nothing. But right. Should I do it?
You're gonna do it?
Should I do it?
Bye, everybody. Yeah, let's do it.
All right, we're gonna try it. Here we go. I have just rendered 1 million items.
But okay, so this is good because it's virtualized.
It's virtualized. It's struggling a little bit, but that's because we're slicing a million item array.
But if this was not virtualized, I guarantee it would break. I guarantee it because I've done it twice and I did it pretty quickly.
Mm-hmm.
I also, if you want to mimic the appearance of a user that doesn't have a fast internet connection, you can disable, what is that called? So if you're using Chrome,
I'm gonna
you
bring this back down.
can
Are you talking about throttling?
throttling. Yeah. You can enable that if you want to.
Here's my throttling.
Yep. Excellent.
Slow 3G. The absolutely brutal. I mean, we're also doing a development thing here, but look at this go.
But that went so fast. I'm telling you guys, break your machine so that you can see how much of a change that that it makes to virtualize your lists. But yeah, this looks really good.
So, and this
So
is, I mean,
fast.
this is going great. So we'll go back to no throttling.
Cool.
But like, this is great. And, we can outrun it a little bit. Like, look, if I'm really racing, I can get a little bit ahead of my virtualizer. And so you could, theoretically, you could say, instead of if it's 0, you could go like 3 items out of frame in either direction, right? Because, that's also a way to make sure that stuff works.
Exactly. Yep. Yep. So you could add, how would you do that? Like add to the start index, you could add like, or sorry, the end index, you could add like +3 or something so that you could fetch the data for the next, 3 items.
Right.
So that
So we could
users
do a
don't get to.
+3, and then we could do the same thing over here with a math.min of 0 or the item -3.
Mm-hmm.
Right. And so now what we'll get is broken code. What did I miss?
I wonder, is it that minus?
Might be. Oh, math max is why. There we go.
Oh, there you
Because
go.
yeah, we don't want it to go below 0. So now it's letting these movies be up here, but we can see in the div itself if I shrink this down. So we're looking at movie 5, but we've got movie 2 in the DOM, but then it'll kind of drop out. So now we shouldn't be able to outrun this, right? Like no matter what, we should always be looking at a complete list. And
That's
so
great.
that's sort of the magic here of this sort of virtualization. And you mentioned before that there are libraries that kind of do this for you, so you don't have to roll your own every time, and probably a lot of edge cases that we're not considering here, but pretty dang cool that we were able to put all this together this quickly.
Yeah, yeah, and exactly. So now you know how it works under the hood. There's I got a question the other day about what's the difference between virtualization and infinite scrolling. So this might be called like windowing, virtualization, or virtual scrolling. So this helps to with the actual rendering part, the painting and the page layout of it. Where infinite scrolling will help is we're only loading the data and fetching the data and loading the JavaScript for a batch of things at a time. So we could add infinite scrolling to this as well and say, okay, we only want to fetch the data for the first 16 movies, or 16 plus 3. And then once the user scrolls past the movie 19, we want to fetch the next batch of 19 items.
Right.
And so that's another way to enhance the performance of your app, so that you're not having to get data for thousands of movies and all of their metadata. You only have to get it for the stuff that's relevant to the user in the current moment.
Right. And so like for example, on the Netflix app, you are loading, say, the preview video, which like those preview videos are as optimized as they can be, but they're still video, so they're big. It's a lot of data. And to try to load, like you were talking about GraphQL earlier, one of the reasons that I think people look at GraphQL is because when you start talking about REST, typically REST databases or REST APIs are built on normalized databases. And so you would get like your first query would be, give me all the movies, and it would give you back like IDs of the movies, right? And then for each movie, you got to take that ID, and so give me the movie with ID X, and then that's going to give you back like the title and stuff. But then when you want your ratings, it's going to say, all right, here's an array of ratings, and then you have to go look up those ratings and then aggregate them. And so you're suddenly looking at, like, for one movie, you might have to make 5 or 6 or 7 or more network requests to load that data. And that's before you have to load the assets, like the trailer and the poster and like any icons or whatever that have to come in. So you might be looking at like over a dozen requests for a single movie. If you try to do that for 1,000 movies on the page, you will crash the browser. Period.
Oh, absolutely. Absolutely. Yeah. And then think about like all the different filtering and sorting that you have to do. So, if you were going to build Netflix, say, you might have the movie Frozen appear in recently watch again, but then also in like Christmas movies, then also in the children's movies. So you have to have different ways of filtering over that information. I'm really glad that you brought up GraphQL because yes, it does that. Like when you think of like a list like this is very simple and we're just getting the names of stuff. But when we think about the ways that we want to make data requests in a way that keeps our app performant, we only want to grab the data for the information that's relevant to the user at the time. If we don't have to get it, we don't get it. So for a list like this, where we're just displaying movie titles, we would want to make a call that only gets the names of those movies. And then we would want to avoid, if it's REST, GraphQL is great at this because it lets you have, it lets you establish connections between normal, like if you were using REST, you might have to make like 2 completely separate API calls. With GraphQL, it makes connections between different pieces of data that might be linked to different like edges and nodes inside of your data org structure. But anyway, so as you scroll through these movies, like you don't want to have to fetch all of that data for movie 19 if that's not in the user's viewable window.
Right.
Or you don't want to have to fetch the information for movie 20 if the user hasn't clicked it yet. Like if that information isn't going to be displayed, don't worry about it. So infinite scrolling, virtualization are all tools that you can keep to help you to not have to do or help your browser to not have to do as much work when it's not necessary.
And it's like one tool in your utility belt as a React developer, or as any developer really. And so, in addition, you mentioned a couple other things that would require some additional techniques. Like if we didn't want to prefetch things, like let's say that each of these is actually, let's just look at Netflix real quick. Because there's a lot going on here. And oh no, I'm not signed in. Dang it. Okay, hold on a second. Let me.
You don't watch Netflix all day.
I watch it on I have it on my TV.
Oh, that makes sense.
Okay, so I'm getting logged in here.
Like or Twitter.
Okay, so here we go. Here is Netflix, and on here we've got all of this information. Okay, and then if I hover over this, it's going to pop up, and there's like this information, and then if I click on it, there's even more information. Oh, don't show me. I don't want to see it though.
It starts to play.
And then I thought there was a like another like look at this kind of thing. It's here, the more info, right? So this more info, then there's even more. There's cast genres, et cetera, and it starts doing like recommendations and all of this. This is a ton of information. Like look at everything that's being loaded in here, and each of these is a trailer, and it's got all this extra stuff, and I can like do interactions and things like that. So each of these, like 2 big images to load in. You've got the trailer. If I hadn't turned off autoplay, it would be pulling in a video. Like there's so much going on here. And let's see, 1, 2, 3, 4, 5, 6, 7 on screen per row. So that's 21 movies right there. 21 movies worth of queries is a ton of data. And the chances that I'm going to look at all 21 of these is super low.
Exactly. So yeah, like as you're for example, you're hovering over Wednesday, then we might be prefetching
Mm-hmm.
the data when you hover over it, and then we actually fetch the data when that, or we actually bring back the data so that it's there in time for you to see the little modal that pops up. Then we might make an additional request once you click into the actual movie, or
Mm-hmm.
click into the information with all the details about it. So yeah, like you said, and if you think of all the different titles that Netflix has and
Mm-hmm.
all of the data that has to go into it, it's a lot. And the connections between different movies, like, this movie is similar to that movie. Um, so that's how it, and Netflix, the TV app is run on React, by the way. So that's how you keep it performant.
Right. And so we're looking at virtualization for the list itself. We've
Mhm.
got all these movies in here. We don't need to load them all. And then we've also got like prefetching, selective fetching, something like if I hover, making queries then so that when I click this, it's probably already there. Yep, there it is. And so you end up with all of this, like, it's a layers of performance, and those choices have to be made for real reasons. Like if I was making a new service with just movies I've made, for example, I have maybe two, right? Like the videos that I've made or something like that. Or, if I'm doing Learn with Jason, I care more because there's over 300 now. So if I tried to load them all and get all the data, it's too much data. I actually ran into this problem where with transcripts now, it's like over 10 megabytes of data if I download all the episodes. So now I have to make choices about which thing I download at what time I download it, or else I'm bogging down the computer and just bringing in tons and tons of information for no reason. And like, the homepage actually or the episodes page on Learn with Jason is becoming a problem because I don't virtualize. It is just every single episode all the way down. Like, this is terrible. I need to rebuild this so badly. um, but
Wow.
yeah, so
You
go
Yeah,
ahead.
we should do one where we like rebuild your site. Like, just add in virtualization. Let's go for
No,
it.
I mean, with what we've done today, I actually feel like I can go in and make a pretty solid dent in this right out of the gate. Wait, what am I doing? I was trying to
Pretty
get.
easily.
Oh, I wanted to resize the window, and instead I was like creating a split view. Um,
Oh,
get over here, and then I'm still kind of figuring out how Arc works. I really like it, but it's got things going on that I'm only sort of familiar with.
it's got
Okay,
things.
so looking at our code here, um, when do you reach for this? Like, I guess maybe the better question is, when is reaching for virtualization not the right idea? When are you like distracting yourself instead of getting work done?
Yeah. So I would typically think of virtualization as a technique when I have a large amount of data that's going to be a similar thing. So like a list, a table, a chart of information. So anything when you're mapping over something, that's when I would use virtualization. Like
Mm-hmm.
if all of your
Over a
stuff
certain
fits
size, right?
over, yeah, exactly. So if it's like a list of things that might go, even if our movie list was maybe 19 things, it just goes off the page a little bit, might be overkill to do it. If we're using virtualization in a lightweight way, like we're using it here, where we're writing all the code and not importing a whole other library, you might want to go for it. But to me, it's kind of excessive. But if you do have lists of, hundreds of things where users are going to have to be scrolling through things, that's definitely when I would reach for something like that. If you are going to be fetching data from that list, I would say infinite scrolling is a very good option. Like I
Mm,
would, in any situation, I would never go like willy-nilly fetching as much data as is there. I would figure out how to minimize the amount of data as much as possible. In
Yeah.
this example, like, we talked about movies, all the metadata that's not shown for each movie, none of that should be fetched until the user is going to see it. So not until they click into movie 32,
Hmm.
or a modal is going to pop up with that exact information that they
Right,
need.
right, right. Yeah.
Faster.
Well,
Yeah.
this is great. Okay, so let's talk a little bit about for folks who aren't going to roll their own. What are the trade-offs here? So you mentioned one thing: if you're just rolling your own, it's lighter weight. You're not bringing in an external library. Why would you bring in an external library? Like, what extra bells and whistles do we get?
So React Virtualized is a way out of the box, and it comes with different props and things that just make it easy for you to plug things in. I'm a big fan of using libraries if they're there because, and I know, like, Brian Vaughn, he was working on the React team. So, like, I trust, there are certain people that, they build something and I'm like, okay, this is going to be pretty solid. And I
Hmm.
know it's going to work well, along with React. So, yeah, I would reach for it if you don't want to spend the time to have to learn to implement something yourself. Like, if you want something that's just kind of, right out of the box. Examples that I've seen of people not reaching for a library is, one, if you are averse to the idea of importing libraries for things that you can build yourself because you want to keep your code as lightweight or you want to have control over it,
Hmm.
or if you have different edge cases. I think I saw a post recently about somebody who, I can't remember exactly why, but their scenario for using virtualization was it would have just been too much work to have to customize React Virtualize, and so they were like, I'll just build it myself.
Hmm.
So yeah, I could see the main trade off though is just like, it's any library you add in is added code. So there's more stuff that your browser has to parse by way of that. If you're doing tree shaking, you're using like Babel or Webpack or something, which I think most apps these days are, or most modern React apps these days are using something like that. Then it's going to shake out a lot of that code, but you are still adding
Right.
in additional code.
Yeah.
But
Seeing
yeah, if your
some
solution is custom, that's why.
shouts
Oh,
in
Tan
the
Stack.
chat to TanStack Virtual. Let's take a look at that one. So here's another option if you wanna check that one out. Um, and so, I mean, from my perspective, what I'm always looking at with like build versus buy, right, or build versus import in the case of third party libraries, is like every line of code you write is a line of code you have to maintain. And so the major trade-off is, sure, it can be fun to write the 150 lines of code that do really clever and performant virtualization. But if you don't need that special use, if you're not hitting an edge case that wouldn't be served by, TanStack or Brian's library or anything like that, then why opt into the maintenance? Why opt into the additional context and the explaining of this tool and the lack of documentation and all of the things that happen when you're not using something out there? I mean, the nice thing about using a tool like this is, look, all the docs are already written for you. You can hand this to your team and they just go. And I'm going to bet money that Brian did the same thing, where it's got, full explanation. Yeah, here you go. Here's how to do it. Here's the documentation. You can go open issues and there's a whole bunch of people talking about this stuff and maintaining it. And so if you don't need the edge case, if you're not hitting something that's not served, and this library is not giant, which I don't know what the sizes are of this library or the TanStack Virtual. My guess is they're not super big. And so the trade-off is very much like, do you really want to own this? Do you want this to be a little tiny product that you got to maintain internally? Because that's not nothing in terms of work.
Agreed. Yeah. Think about scalability. If another teammate comes by and asks you, how do you do that? You could just, say, hey, use React Virtualize, here's the docs.
Mm-hmm.
Or you can give them a whole rundown on how you built it and try to remember all the stuff that you put into it and the weird edge
Mm-hmm.
cases and things. So yeah, I'm a big fan of leveraging open source,
Yeah.
other people's trusted work.
And the thing is like every single company 100% will have edge cases where you need custom stuff. That's why internal tooling teams exist. So
Exactly.
don't overburden your internal tooling team by opting into creating things that don't need to be recreated, because they're going to need that brain power for all the little fiddly crap that's unique to your company.
True.
Anyways, yeah, I think this is wonderful. I did see there were a couple questions in here that I just want to address. Mr. Nike guy asked, how does Chrome know the max height of the real movie list? It's because we are specifically calculating it here. We do the inner height, and then we set it on the inner box here. And that way the box is always the size of the full list, and then we're just rendering in the items as they're scrolled into the viewport. Let's see. Don't see any other questions, but I do see Henri. What's up, Henri? Shaundai, where should people go if they want to learn more about virtualization or more about you?
For virtualization, I would check out these libraries. I would look up, so when you look up virtualization, look up windowing. There's a lot more resources that come out on that. And
Like React windowing?
Yes, yeah. Or yeah, Googling is such a tough thing. Yes, so perfect. So optimizing performance, that one's a great article. And then there's a Medium article that I had found, which
And we also have a question. I think this one came from Twitter. Would you be able to recommend the tools you use to profile a Next.js app? How would you approach an existing web app to optimize performance with a focus on server rendered endpoints? I feel like that was one we saw on Twitter earlier today, right?
Yeah, that was. So yeah, that was a great question. So server rendering, this example could fit into server rendering. The biggest area for performance in my mind is the fact that when you're fetching data, the request a lot of times will come from the client and then go to the server, and then the server has to send that information back over the network. So I would think of performance optimization in a server rendered app in terms of how can I best fetch data? Like, how can I fetch the least amount of data? How can I make the fewest amount of calls? And we already talked about only fetching the information that's going to be relevant to your users and what they need to see right now.
Mm-hmm.
Also, there are techniques that you can use to split things up. And I don't want to go over time, but I could go on a whole rant about not rant, but like a good rant about suspense, streaming server rendering, selective hydration. In React 18, they came out with an enhancement that's like right out of the box, and you can use this in Next because they work very closely with Next in the updates that they have. Previously, all of the steps to a server rendering process, the fetching the JavaScript, fetching the data, the loading the JavaScript, the rendering to HTML, all of that had to happen for the entire application at once. With Suspense, what you're able to do is specify, like, you just wrap a component in Suspense and say, okay, this information might take a while to come back. I'm going to specify a fallback, and there's going to be a loading spinner in its place. Now, with streaming server rendering and selective hydration, you don't have to do all of that in one pass. Like, you can split your app up. Like, if we look at this React page right now, we could split up the right-hand nav from the loading of the header. And if that header is really quick to come in, we can just like show that. And kind of like streaming in the same way that I would think of, I have a weird picture in my head, but like you just think of it as just like a stream of information. Once the information for the right nav comes in, if it comes in later, it's just going to pop in and it's going to come in the right place. And for the user, all they see is like a loading spinner while it's loading. But that's after you've already optimized for like fetching data and all that stuff. So some things that I would look at to recap is if you're using React streaming server rendering with Suspense, selective hydration, and then think about the way that you are making those data requests, those requests for
Yeah.
your information from the
And like check the network panel too, and just look at like what is coming in and is it being used? Because one of the things that'll happen in a React app is that when you're doing the server side rendering, again, you're loading the data once to put into the server, and that's in the HTML. You're loading the data again to put in JSON, and that's at the bottom of the app. In the case of Next, it's in a script tag called that's prefixed with a const called next data, and you can see everything that's being loaded on the page. And so that's extra stuff. Then you have to download the JavaScript. Then your JavaScript has to mount, read that JSON blob in, parse it, process all of those components, and like turn the static HTML into a working React app again. And if you're not using the things that you are rendering, like this is why I think we're seeing so much discussion about like, do you need Next at all? Because a lot of people are using Next to server side render something that's not dynamic. And so you're like getting static HTML, and then it should be static HTML, but you're doing all this work to like re-render it into a dynamic app that has no interactivity whatsoever. And so that's, I think that's the other piece too, is like, do you need Next.js at all? Because in a huge number of cases for the internet, like the sites people build do not need to be built in React, like just period. Like, are you displaying data? Does the data have any interactivity? If the answer is no, do you need a JavaScript like maybe just put some HTML on the page, right? So first, make sure you're using the right tool for the job. And then second, look at what the tool is doing. Look at that network tab and the flame chart for like how much memory is being used and how much work your browser is doing to render the page. And just, make sure that you're making choices on behalf of your user that actually make the experience better. Like React is great when you have something that needs a lot of interactivity. Otherwise, you're making the browser do work for no reason.
Yes. Preach.
Shaundai, with that,
Preach.
I think we're about out of time. I feel like I kind of jumped in as you were about to talk about another resource. So I want to make sure if you had one in mind that I didn't cut that off.
I had a Medium article. I was listening to you and I forgot to find it, but
no worries.
I'll tweet it out. I think they have enough resources. But if anything, yes, I was going to say, find me on Twitter. I'm still using Twitter, but if I decide not to, I will let you know on Twitter that I'm moving.
Looks like, and we got a link tree, everyone. That's what you really need. That's the jam. Get on that link tree and just click every one of those links.
That's right.
All right.
Yeah.
With that, I'm going to do another shout out to our sponsors. We have this episode, like every episode, has been live captioned. We have had Rachel with us today. Thank you very much, Rachel, for being here. And that is through White Coat Captioning. Thank you, thank you, thank you. That's made possible through the support of our sponsors, Netlify, NX, and New Relic, who has a ghost logo. Thank you all very, very much for that. While you're checking out things on the site, make sure you go and check out that schedule. We've got so much good stuff coming up. I cannot wait to do the rest of this. It's going to be we're going to close out the year strong. I'll just get ready. And there's more here that I haven't put on the site yet, so just buckle up. Follow on Twitch, subscribe on YouTube. You can add this Google Calendar to get the details, like any number of ways you can get involved. I want you to hang out. I'd like to be friends. Shaundai, it's been great hanging out with you. Thank you so much for spending some time with us today.
Thank you for having me. As always, it was fun.
Awesome. All right, y'all. We are going to go and raid. Let's see. Martine Dowden is up and running. Let's go see what Martine's up to. Thank you all so much. We will see you next time.